A 45 kilogram girl is standing on a 142 kilogram plank. The plank, originally at rest, is free to slide on a frozen lake which is flat and frictionless. The girl begins to walk along the plank at a constant velocity of 1.43 meters per second relative to the plank going to the right. What is her velocity relative to the surface of the ice, and what is the velocity of the plank relative to the surface of the ice? So we have the mass of the girl, which is 45 kilograms, the mass of the plank, which is 142 kilograms, and the velocity of the girl relative to the plank, which is 1.43 meters per second. So we need to find the velocity of the girl relative to the ice. And to do that, we need to think about, we can draw a free body diagram. So if this is the girl walking to the right, the plank is going to be sliding to the left because it's frictionless. So it's going to end up being the velocity of the girl relative to the plank going to the right plus the velocity of the girl, or the plank, to the ice, which is going to be going left, but it'll be negative. We'll figure that out. So in order to do this, you can use this equation. The total momentum of the system of two particles is the total momentum is equal to the momentum of 1 plus momentum of 2. So, and momentum is equal to the mass times velocity. To do that, we can do, it's relative to the ice, so the mass times the velocity of the girl plus the mass times the velocity of the plank, both relative to the ice. Final is going to be equal to the momentum of the initial, and since the plank is originally at rest and the girl begins to walk, this means that the velocity of the block and the girl initially is going to be 0. So the whole right side of the equation is going to end up being 0. And now we can solve for either the velocity of the girl to the ice or the velocity of the plank to the ice. And I'm just going to solve for the velocity of the girl to the ice. So we can subtract this over, and we get negative mass times velocity of the plank to the ice divided by the mass of the girl. Mass of the girl, mass of the plank. And that's going to equal velocity of the girl to the ice. So we can plug this value in for VGI here, and we get negative MV PI over mg is equal to, we know the velocity of the girl to the plank, it's right here, 1.43 meters per second, plus the velocity of the plank to the ice. So now we're just going to do some algebra. We're going to add this over. I'm going to get the velocity of the plank to the ice relative to the ice is plus this equals 1.43. And subtract 1.43 over. Factor out the velocity of the plank to the ice here. So we get the velocity of the plank to the ice times the mass of the plank divided by the mass of the girl plus the velocity of the plank to the ice. And now we can factor out VPI from this whole side. We get velocity of the plank to the ice times MP over mg plus 1 is equal to negative 1.43. And so when you factor this or distribute this back through, you get VPI times this, which is going to equal this, and VPI times 1, which is going to equal that. So we can divide this part over to this side, and we get negative 1.43 divided by this equals VPI. So negative 1.43 divided by the mass of the plank divided by the mass of the girl. So 142 divided by 45 plus 1 we end up getting a value of negative 0.344 meters per second for the velocity of the plank to the ice. Now we need to find the velocity of the girl relative to the surface of the ice, and we can use this equation again. So we know that the plank's going to be sliding to the left, or negative 0.344 meters per second, and the girl's going to be going to the right, which is positive. So we can use this equation, VGI is equal to 1.43 for the velocity of the girl to the plank, minus or plus a negative 0.344. And we get 1.1.0 meters per second for the velocity of the girl relative to the ice.